Welcome back. We are continuing our practical applications with Autodesk Inventor, and this is exercise number 3. We are designing and 3D printing a whistle. This project is a great way to practice using commands like line, arc, circles, extrude. Obviously extrude never goes away. Sweep command, we're gonna see also sweep command. All right, sweep is very interesting, my friend. It's a very interesting command. Allows you to make complex shapes, complex models. Sweep command. Those of you who are sitting for Autodesk exam, you definitely need to pay attention to this one. You're gonna see sweep on your test. Okay, what else we're looking at? You know how to fillet. We're gonna look at a plane tool and these different options. What does all of these different options do? We're gonna go one by one. In exercise number 2, we did look at mid-plane between two planes. We're gonna see it again. I'm gonna use it again today. We're gonna explore parallel to plane through point and more and more. So let's get started. Let's look at our dimensions of this whistle. So what I'm looking at here, if I cut through, let me zoom out a little bit so you can see, maybe 6, 7. Yeah, this 6, 7 is fine. Looks fine. Maybe 6, 5. Let me do 6, 5. All right, so from here, if you're going to cut through from this is the top view. If you slice your whistle through here, this is what you end up looking at. This is a cross section view. All right, so it looks like the outside, this outside circle is, the diameter is 14. The inside circle diameter is 11. What else we got? So we got this distance there, the opening. And then that. Yeah, so this is what we got. And the arc, this arc is 32, radius 32. Let me pause here. So if you wanna try on your own, go ahead, take a picture. Go ahead, take a picture and give it a try. See if you can figure it out on your own. If you can't, that's totally fine. We can work this together. So you got something like this. Where do you begin? Where are we gonna start? Where should we start? Okay. All right. Think about it. Let me know where do you think we should start. All right. Let's go to Autodesk Inventor. Autodesk Inventor and what? Start a new file. Select file. New. We're gonna be working the metric. Yes, let's work in the metric. Create. Wonderful. Step 1. Start a new file. Create. Alright. What do we do now? Start a 2D sketch. Sure. Which plane? Let's select XY plane. XY plane. Why do I select XY plane? Because I'm gonna 3D print it, and my 3D printer, the front plane is the bottom plane. So XY plane works perfect for my 3D printer right now. Now what? So we started 2D plane. Now what? What do we do next? Line, arc, or circle? What? Tell me what to do. I have no idea. All right. How about we start with a circle? I'm gonna start with a circle. Let's go ahead and draw a circle. What's the diameter, you ask? 28. Draw another one. Maybe I went too fast. I forgot I got too fast. Alright, draw another circle. Just click one, enter dimension 22, and then enter, my friend. 2 circles. Now you have 2 circles. How can we access circle command? Escape twice or right click, set OK. Again, if you press escape twice, it does the same thing. Done. Now, where these dimensions came from, let's go back. That's the radius is 14, so diameter is what? 28. The radius is 11. Diameter is what? If radius is 11, diameter is, I had it, 22. Okay, that's where these dimensions are coming from. Awesome. Now what? Let's go ahead and draw a line across from this point to here. So I'm going to draw a line from here. Make sure it is perfectly vertical line. 90. Awesome. Awesome. That's a line. How do we know it's perfectly vertical? Look at that constraint. Vertical constraint and the constraint tab here. It is showing. That means your line is straight. Straight as a ruler. Straight as edge. Awesome. Now select it. Left click to select your line. Left click. And then right click. Make it a center line. Okay. If you don't want to do that, if you don't like that, also left click and you go to format, find a center line. Okay, there are multiple ways to do the same thing. One way is probably faster, more efficient, work more efficiently, work smarter, not harder. Awesome. So we got a center line. Now what? Now what? Now what? Now what? So let's draw another line from this point. And we're gonna make this line, the length of this line, let's make it 35. Go down. How far? Let's make this 12. Enter. By the way, you are welcome. You're welcome to, once you design, this is a design class, so you are welcome to modify all these dimensions. All of these can change if you want. And see how it turns out. I 3D printed this and it worked mine, but hey, maybe yours work better than mine. Feel free to modify this. Maybe do 37 here if you want to. I don't know. It probably work. Alright. Now let's go to arc command, and this time look at that. Arc command. Select this drop down here. You see multiple points, the multiple ways to create an arc, multiple types of an arc, I suppose. Let's go ahead and use 3-point arc. 3-point arc. What does that mean? What does that mean? So you're gonna click on point 1 about here, point 2, click, and give it a diameter. Click for your diameter. Alright, let's go ahead and do 32. Let's try 32. Try 32. 32. Excellent. Excellent. We got an arc there. Now, under constraint, next to dimension 2, where you find a way to see dimension 2, we have all these different constraints. The circle and line is tangent. It is tangent. It is a tangent. It's gonna make this arc and the circle tangent to each other. Let's do that. Select the arc and then select this line and makes them, the circle. It makes them tangent and it creates this smooth transition. Excellent. Alright, right click, select OK again to exit the command, or place escape twice. Escape twice, whichever you prefer. They both get you where you want to go. Okay? Now what? Now what? What is that dimension? Where are all these dimensions at? Somebody said I'm making this stuff up. Where did I get this stuff from? Show me the proof. Show me the truth. The proof. That is 12 and it's 32. 34. Okay? What else is there? Where's there? What else can we do? What else can we do? Let's let's go ahead and from here, let's draw a line from this side all the way to here, and make sure that your line is horizontal. You see that horizontal constraint, which is this guy, horizontal constraint. That means it's perfectly horizontal. All right, let's do the same thing here, but this time it's not gonna be perfect. So let's do a center line from there to here, to the inside circle. All right. So dimension 2, select this line and this guy. Let's make it angle of 94 degrees. 94 degrees. Let's double check, make sure that we got that right. 94 degrees. What is that angle? So it's this part here. 94 degrees. 35. That 35 distance, this 35 is this distance 35 here. So we are cooking, ladies and gentlemen, we are cooking. I don't know what we cook. Maybe we're cooking steak. Maybe we're cooking a whistle. We are cooking a whistle. Whoever says that, my engineering club says we are cooked. They like to say we are cooked when they see the competition. Awesome. So we got that part done. Now let's draw another line from this point to here. Nice. Now what's this distance? Let's measure from here to here. Make that distance 4 millimeters and then enter. 4 millimeters and then enter. Okay. What about this distance from here to here? 4 millimeters. Maybe this is a point. This is where we should talk about exam question. On your exam, they're gonna ask you. They're gonna give you a 2D sketch. I don't know what it's gonna look like, but they're gonna give you a 2D sketch and say, "Hey, how many dimensions do you need?" Or is this, how many dimensions do you need for this sketch to be fully constrained? How do you answer that question? Just look at the bottom. One dimension is needed for now. Who knows? Sometimes you may have 8 dimensions needed. Just look at the bottom right corner. It tells you. All right. So we got that done. What else is there? Let's look. How far are we? Okay, so that we need to get part and this part, this distance. And I believe we're done. I believe that's it, ladies and gentlemen. It's not that hard. Alright, let's go ahead and draw another line from here to here. Okay. What's the angle? I remember this one. This angle needs to be 53. Okay? Wonderful. Now, how the hell does this look like? How are we gonna make this thing a whistle? Anybody sees a whistle shape already? Huh? Let's look at another command, another powerful command. Trim, my friend. It's trim command. Trim. Trim is like a delete command, but of selected area. So we don't need this part. Go ahead, delete. Trim that out. Also trim this part out and this guy out. Boom. Move the dimension away so you don't get confused. So we have this opening. And let me go back to the drawing and I show you what's going on. Let me rotate this so you can see. What's going on. Alright, so this is my drawing rotated. The air, you're gonna blow your whistle through here. The air is gonna come in through here. It gets down. It keeps coming, it rotates all the way and then goes out. Boom. Those of you who are interested in aerodynamics, this will be a good project. Learning how does a whistle work? How does a whistle work? Alright, so yeah, you're gonna find out. If you go to engineering school, they're gonna teach you a lot of things you design, a lot of things we take for granted, but they are very complex. They have complex fundamental principles, engineering principles, like a whistle. Simple but complex at the same time. Okay, so that looks like what we have almost. There's coming through here. Boom. I mean, that and then out. Okay? One, done, done, done. What? So we still, 3 dimensions are needed now. You see that? 3 dimensions. Okay? So our sketch is no free constraint. Also, when you see, look at that. Look the color of my lines. These paper lines, that means that they can move at a point. So we need to free constrain our sketch. When it's free constrained, the color is going to change to black. So let's add more dimensions. So from here, for instance, to here, the vertical distance, let's make it 3.6. Now we got 2 more dimensions. We still need 2 more dimensions. What are those dimensions? Okay. What are those dimensions? Alright, what about from here to here? Can we make that? Let's make it at 9. Say we need 1 more dimension. I have no clue. I have no clue what dimension is that. If you know what this dimension is, you are a genius. Comment, let me know. Let me know what we need. Alright, so this should be able to work though. Because this is what I had. I had something like this. Alright, 3.649. What is this 9? This distance is that part here. Okay? That's 9. 4, 3.6. Am I missing anything, ladies and gentlemen? Am I missing anything? Am I missing? I know that this distance doesn't really matter. I know the distance doesn't really matter. Ah, that's what they want. They want this distance to be 27. Okay, gotcha. Now it's a free constraint. Did you see that? Free constraint. I missed that. Why? I was so blind. This is 27.4. How could I miss that? Hey, it's design. Feel free. I did 27 there. Maybe try 27.4 and see how that's gonna affect your design. Okay. Now our sketch is free constrained. We can finish and do magic. Finish and do magic. Whoa, 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 whoa. Why did this line move? Huh? Why did this line move? Let's see if I can apply constant constraint. We want this guy to be, I want to do it. I want to do it. Okay. Well, we don't need this center line anyway, so let's go ahead and delete it. It was just there. Alright, now finish your sketch. Let's go ahead and finish our sketch and extrude. Extrude, you guessed it right. We're gonna extrude. Alright, how much are you gonna extrude? What are you gonna extrude? Which profile? Select that profile, select everything. And this one too. How much? Distance A. Keep your direction to default and click OK. Again, this is a matter of preference. You can extrude 3. There is no reason why it won't work if you extrude 3 or 4. It's just gonna be thicker. Alright? I'll try it and see how it does. I'm gonna do 2. I'm gonna keep it at 2. Awesome. That part is done. Now your sketch is, where is your sketch, ladies and gentlemen? Where is your sketch? Okay. Shift and wait button if you want to see. If you want to rotate and see different sides. Or use the view cube if you're in the kindergarten. If you're in the kindergarten. I'm joking. Class. If you're in the kindergarten and you can do this, you are alien. You are not a human being. You are an alien. Okay. Alright. Alright, what else can we do? So, what is our sketch? Somebody tell me what is our sketch? When you extrude, your sketch disappears, but you can bring it back. If you want to extrude again, bring it back. So left click to select it, then right click, make it visible, or just do it here. I mean, check visibility here, or just come turn this right on. It does the same thing. Now the sketch is back. I'm going to rotate it where I can see the back, this back side. Okay. And I'm going to extrude it one more time. Extrude it one more time. And this time I'm going to select this profile, that profile, and this profile. I'm going to do direction is going to be flipped. So if I shift and rotate, see where it's going. Do you see a whistle? What about we do this distance? How about we do 20? Does that look like a whistle? Yes or no? I heard yes. Alright, so make sure that your output is unjoined, but direction do flipped. Okay. And then click OK. Click OK, ladies and gentlemen. Now, do we still need that sketch? Do we still need that sketch? So go ahead and check that and check visibility. And we got almost got our whistle done. All right. Now, what else can we do? So to do this side, this side looks like this. This is exactly what we need to do. Now, do we have to start a 2D sketch, draw a circle, draw lines like we did before? Or we can be smart about it. We can be more efficient. Take the advantage of what? Project geometry. Select this file. Select everything you see. Create this yellow outline. This is just the first sketch we started with. See? That's 12. That is 35. That is 9. But we just did it with 2 clicks. We took advantage of project geometry. Okay? Now finish sketch. And I probably missed this. Was there this part? I don't remember. Maybe not. Now let's go ahead and extrude it. Extrude it. How much? We're gonna extrude to flipped. Alright, we need to extrude that guy too. What about that guy? There you go. So make sure you have 3 profiles selected. What distance we did before? 2. And done. Almost done, ladies and gentlemen. Almost done. Now let's go ahead and fillet. I know you're hungry. Filet mignon. Chick-fil-A, whatever meal you like. What's the radius? Let's do 1. Just 1. Type in 1. So the radius is 1. Select that profile. Select that edge. Okay. That's for aesthetics, utility, or safety reason, but it can still work. Okay. Alright. And then click OK. And go ahead, dress it up. Ladies and gentlemen, go ahead, dress it up. If you want, go ahead, select a material that you like. Select the material, maybe forest green. How does forest green look like? I don't know. Select the material you want. Don't matter. LED lights on. Green. Green. That would be nice. Nice looking pet whistle. If you are in my principles of engineering and technology, this is where you can stop. I don't mind. I don't mind if you stop here. Unless you want extra credit. If you want extra credit, see if you can finish the rest. That's extra credit. Okay? That's extra credit. Also, if you want to 3D print, remember what do we do? Indeed, I highly recommend you 3D print this and see how it works. Impress your friends lunchtime. Borrow the whistle lunchtime. Okay? I mean, probably don't do it lunchtime. But if you see somebody, if somebody's being mean to you, borrow a whistle. The assistant is gonna come to you. The admin team is gonna come to you right away. Somebody's looking at you weird. Somebody doing something suspicious. We definitely live in one of the most dangerous cities in America. So yeah, next time you go for a walk, next time you go walk your dog, bring your whistle with you. Okay? Something is strange, borrow it. The people around you will definitely pay attention. All right, so let's say you want to 3D print it. Where do we go? File, export, CAD format, STL file, always STL file. Okay, I'll show you how to slice it for 3D printing next time, hopefully. Okay, cancel that. But save it if you wanna 3D print it. You have to save it as a STL file first. Okay. All right, and yeah, save it in your folder. Also, if you wanna save, let me show you how to save again. Some of you may have forgot already. File, save as. You wanna save as in your folder. Find your folder on your desktop, put it in there. Okay. Now there's different file types. So this is gonna be IPT. Okay, cancel that. That's it, my friend. That's it. So those in STEM 2 and STEM 3, we're not done. Don't go anywhere. We had one more piece to do. Actually, I don't want this video to be too long, so I'm gonna do it in part B. So you guys are gonna do part A and part B. So part A is getting here. Part B is going to create this handle part and then also creating the ball that goes inside. Okay? What command are we going to use to do that? Think about it. How are you going to create the part that goes inside? Because right now, if we look at it, if we do a cross-section view, let's go to view, and then select section view, and then half section view, select this plane, and then move point your arrow towards there. You see? I'm moving mine towards negative. Let's do negative 12. And then enter. Now you see the air comes in through here, right? Down, out. Down, out. Where is that piece? The piece that goes in there? It's not it. Does it make a difference? Maybe. Maybe it doesn't. I bet it does. But we're gonna learn how to do that in part B. Okay? So go back to view. A section view already exists. Click yes to edit section view. Click no to delete. Click no to delete. Yep. Nope. Awesome. Done. Alright, ladies and gentlemen, I will see you in part B of exercise number 3. Oops, what happened? Undo that.